This lesson is going to look at another way of solving quadratic equations, this time using factoring. So we have our quadratic equation, x squared plus 5x plus 4, and by showing you the quadratic formula, you can see that the roots are x equals -1 and x equals -4. So to solve this same equation using the factor method, we have to look at it as it's written as the product of two binomials. So the equation that we had was x squared plus 5x plus 4 is equal to 0. If I was factoring this, I would need two numbers that multiply together to make 4. So my factors of 4 are 1 and 4, or 2 and 2. And they have to add together to make 5. So that's 4 and 1. So this tells me the signs are the same, and this tells me they're both plus. So my factoring is x plus 1 and x plus 4, and that's still equal to 0. And what we know about multiplying something to equal to 0 is that one or both of those things has to be 0. So what solving by factoring does is that it allows us to take each one of the factors, because we don't know which factor is equal to 0, and set it equal to 0 and solve to figure out what the roots are. So if I were to solve the first factor, x plus 4 equals 0, I would have to subtract 4 from both sides. Those two 4's would cancel each other out. I'm left with x being equal to -4. And this one I would subtract 1 from both sides. The 1's would cancel each other out, and I'd be left with x equals -1. So my roots are x equals -1 and x equals -4, just like it was with solving it with the quadratic equation. Let's take a look at another one. So I want to rewrite this in factored form. So this one I'd be looking for two numbers that multiply together to make 6, which my choices are 1 times 6 or 2 times 3. And then I'm looking for them to add together to make 5. So that would give me 2 and 3. So if I'm factoring, this tells me that my signs are the same, and this tells me that they're minus. So I'm going to have x minus 2 and x minus 3. And then that's set equal to 0. So if I'm going to set each factor equal to 0, I have x minus 2 equals 0 and x minus 3 equals 0. I can then solve both of those to figure out what my roots are. So minus 2, to get rid of it, I have to add 2. Minus 2 and plus 2 cancel each other out. I'm left with x, and then 0 plus 2 is 2. Here, to solve this one, I would have to add 3 to both sides. Minus 3 plus 3 cancel each other out. I'm left with x, and then 0 plus 3 is 3. So my solutions are that x equals 2 and x equals 3. This one is a little bit more complex. So let's take a look at this one. I have 2x cubed minus 10x squared minus 12x. I want to factor these. So I want to start by factoring by pulling out a common factor, which would be 2x. So I'm going to pull out 2x, and then if I pull out 2x out of 2x cubed, I'm left with x squared minus, and then if I pull 2x out of 10x squared, I'm left with 5x. And if I pull 2x out of minus 12x, I'm left with minus 6. So I then have to rewrite the equation in factored form. So I have to see if I can factor this. So I'm left with 2x for sure. And then if I'm just looking at factoring this part in the parentheses, I have x squared minus 5x minus 6. So that would mean I'd be looking for two numbers that multiply to make 6. So it would be 1 and 6, or again 2 and 3. But they have to subtract, because it's minus 6, to make 5. So that would give me this one. So they're both negative, or this tells me here that the signs are different, and this tells me that the bigger one is the minus. So I would have x minus 6, because 6 is bigger than 1, and x plus 1. So this time, if I'm writing in factored form, that has to equal 0. So this time, 1, 2, or even all 3 would have to have been equal to 0, as somehow they equaled 0 when they multiply together. So I want to set each factor, no matter how many of them that there are, equal to 0. So I could set 2x equal to 0, x minus 6 equal to 0, and x plus 1 equal to 0, and then solve each one. So this one I'd have to divide both sides by 2. I'm left with x, and then 0 divided by 2 is still 0. This one I would have to add 6 to both sides. The 6's would cancel out. I'm left with x, and 0 plus 6 is 6. And this side, I'd have to take away 1 from both sides. 1 minus 1 is 0, so I'm left with x, and then 0 minus 1 is negative 1. So my roots of this equation are x equals 0, x equals 6, and x equals negative 1.